information we have this is 6 centimeter. Are we doing for paraxial rays? The first question we have to ask it. I think if the paraxial ray, I don't mention this one, no. So is it a paraxial? No, it's a marginal ray. Like that, we have some 15 types of rays are there. What we can do for marginal rays? Lot of mass is involved. That's why to minimize that, we are coming for paraxial rays only. So is it a paraxial? No, it's a marginal ray. If you want to write it here, it's a marginal. Will you apply any formula? No, we don't any formula. We should just stick on to the basic geometry and calculate where it will strike it. Okay. Now get into the mathematical part. This will be the angle of refraction. This is the angle of incidence theta or right eye. This angle of refraction r, because this will be the normal. This is the P, you write it. This may not be needed. So what can be this angle? This angle should be pi minus r. This angle should be I. This angle will be r minus I. Okay, what was the question? Only we have to get that x. Let's apply the Snell's law at point P. At point P, sin I mu sin I equal to 1 into sin R. So mu is given 4/3. Do we know theta? Sorry. Do we know I? Radius of curvature is given. So what is radius of curvature? Shall we call this is R? And we know triangle. So sin I we can calculate very easily. Sin I equal to 6 by radius of curvature is how much? 10. So 3/5. 4 into 3, 3/5. Sin R will be 4/5. Anybody value of R? 53 degrees. Now we have to calculate that x. Let's look at the triangle. From triangle CPI, we should calculate this distance x. Okay, what can be this distance? The remaining this distance should be the r. No. Can we apply sine rule? Applying sine rule, sine of r minus I by Cp should be equal to sine of pi minus r by Ci. Cp is how much? 10. So we know R, I, all the values. Solving, we'll get the expression for x. So when marginal ray comes, what is the problem? Like this, so much of mass is involved. That's why we avoided. That's why we made all the discussion for only paraxial ray. So whenever from optic axis, if they give the position where the ray is incident is striking the lens. When they give no, it is understood it's a marginal ray. So a lot of students, what happen, they want to apply the formula lens, like a lens equation, like what is the problem with this? Why we can't use this one? This is derived for what? Lens maker formula, the lens equation, mirrors formula, everything is what happened. The discussion was made with respect to what? With respect to paraxial rays. What we have is marginal rays. So these formulas are not applicable. That's why we are taking help of this mathematics here. A possibility of asking such questions in advanced exam. Mains may not be, advanced possible.